haven't covered in enough detail and that I would like to emphasize. Okay, so let's take a look at the LEGO Mindstorms EV3 software, and we want to create a program that makes the robot go straight. So in order to do that, we first go on New Project, and we open a program, and we click Open, and then you typically need to wait for a little bit. So here we now have the programming environment to create a new program. First thing we're going to do for now is remove this comment block, and our program starts with this play button. Now we want our robot to move straight forward, and there are two options how we can do that out of the green action palette. The first option here is the move steering. So if we take the move steering block and connect it, then you see that by default the block in the software assumes that the two large motors, which you see here, are connected to port B and port C on your EV3 brick. So that's something you need to verify. We have different modes. We have off, on for seconds, on for degrees, and on for rotations. We will keep it at on for rotations, which is the default. And here we see the robot has a steering of 0, so it will go straight. And then it will do that at a power of 50 for both motors for one rotation. And finally, it will brake. So this is one way to program your robot to go straight forward for one rotation. And if you want to test that program, you need to connect your switched on robot to your computer, and then you can with the USB cable, and then you can press the play button here, and as you do that you will see the robot execute the program. You can also go to the bottom corner here and press the download button, and then the project will be downloaded onto your EV3 robot, where you can then find it. Now before you execute a program, you want to save it. So see up here at the moment, it's called project, which is the default name, and there's an asterisk next to the project. That means that basically this program hasn't been saved yet. So let's give our project a name that we can remember. So let's call it straight one rotation and save it. You see the asterisk has disappeared, and now we have a name that will show up again on the display of the EV3 robot. And we also don't want this to be called program, but rather give it a name that we will remember. I'll call this steering, because I used the steering block here. Okay, let's add a second version of doing exactly the same thing, go straight forward for one rotation at power level 50. So new program, and this time we're going to use the move tank block. And if we keep all the parameters in the default, then you see again it's set on for rotations, power level of 50, one rotation, and finally brakes, so it'll do exactly the same. Here too, we want to have a name that makes sense. So let's call that move tank. And now you see we once again need to save our program. We can do that either up here with the file save project, or we can simply click on the save project here, and now the program has been saved. So let's take a look at what will happen in reality if we execute one of these two projects. So here's the first program of the robot. What's your robot doing?
It is going to go forward for 1 rotation of the wheels.
You want to try it?
Okay.
So how can you verify that it's really 1 rotation?
That's how we programmed it.
Okay,
Yeah.
but that's what the program claims. Now how do we know the robot does what it's supposed to
What
do?
we can do is we can make a white mark at the one side and then just watch where the white mark ends up at the end of it.
Okay, if you look at your wheel and the axle of your wheel, there's this white pointer. Can you use that?
There you go.
Yes.
Okay,
That's the white mark.
so let's press the button and see. Up.
And it
Yep.
went around once.
And it went around once. Cool. So how far will it go with 1 rotation?
So the distance will be as the circumference of the wheels.
Okay, so let's see if we can, how can we verify that?
Okay. So the idea is that we start at the edge of the ribbon, and once it has 1 rotation, we're going to pull the ribbon up to show that it is the full circumference and not any more or any less of the distance.
So let's see.
Full circumference.
So you need to understand that robotics isn't an ideal textbook world. If we look at the programming block on the bottom, which makes the robot go forward for 1 rotation at power level 50 of both motors and then brakes, you know that if it was an ideal textbook world, then only the size of the wheels should matter in order to determine the distance that the robot travels, but the profile of the tires, for example, shouldn't. However, since different tires have different traction, it actually will influence the result, because also the surface on which the robot operates, because the robot might slip more or less depending on the tires and the surface. Also, the power level of the motors shouldn't matter. In order to determine the distance with 1 rotation, it should go every time the same distance. And if you repeat your program, it should go the exact same distance every time, which it roughly will, but there is a little bit of difference depending on the traction and friction. The slower you move the robot, so the lower the power level, the better you get repetitive results. Now let's look next how we can use our programs to make the robot reverse 1 rotation. So instead of going forward, the robot will go backward, and we start off with our go forward blocks on go forward programs that we've created before. And if we look at the version that uses the move steering block here, you see, and click on our arrow, you see you can kind of like have a slider turn to the left, turn to the right, but there isn't really a way to make the robot reverse. What you can do to make it reverse is you can look at the slider here for the power level, and when we make our power levels negative, you see the arrow has flipped its direction. So now the robot will not go forward, but it will actually go backward. And if you want, let's say we want it to reverse slowly, so let's pick a number that is negative but close to 0, so let's say -10. So now our robot would reverse at power level -10. You also see there's less power here indicated for 1 rotation, and it will then brake. Now let's see how we do the same thing with our move tank block. So if we take the move tank block, at the moment it's going forward. So again, here, if we change the power level to something negative, then the motors will rotate in the opposite direction. So we can just go do -10 and -10 and keep it at 1 rotation. So with the move tank block, it's important in order to go straight, regardless of whether it's forward or backwards, you need to keep the power levels of the 2 motors the same, where this one is the power for motor B and this one is the power for motor C. Now you could download your program now onto your robot and you can test it, but then you basically have overwritten your original project. So before you do it, save your project under a new name, because we're now doing something different. And I call it back one rotation. So now I have two projects. If I download this one on the robot, I can first run the straight one rotation program to make the robot go forward for one rotation. And if next I execute the back one rotation, it would reverse the same distance, because it's again one rotation, but at a lower speed. Okay, so let's assume we want our robot to go out for one rotation and then reverse back. So let's add a new project and apply what we've learned. Make this a little bigger. So this time we're going to use the move tank block for the going out one rotation. And you see all the default parameters, we keep them. For reversing, we're using the move steering block. So if you want to do two actions, you need to have two blocks. The first one for going straight forward, the second one for reversing. And it's just personal preference that here I pick once the move tank, once the move steering block. Now we need to go in the opposite direction. We also want to reverse a little more slowly. So let's put this to -10. So this actually would work. However, that's kind of like shifting in your car from like fifth gear directly into reverse. What we want to make sure is, well, we said the robot has to brake here after moving forward, but we want to make sure that it actually stands still before we reverse. And we haven't talked much about the flow chart, the flow blocks yet, but here's an hourglass, a wait block. So if you go from one action to the next, it's always a good idea to enter a wait block. So here it's set on wait for time, and if you look at it, its default is 1 second. You can also say like half a second, 0.5 is enough. And now if we try the program, the robot goes out at power level 50 straight. It stops. It then waits for half a second, and then it reverses slowly the same one rotation distance. So again, don't download it directly, but save your project. Let's call it out and back. Okay, now we have a new project, and maybe here we call it one rotation to remember how far we want to go out and back. So finally, let's talk about turns. Here we have our straight one rotation project again with the two versions of going straight, and we're going to modify it such that our robot will turn. So first of all, let me rename the project and go to Save Project As, and we'll call it Turn. Okay, so we start with our move steering block, and in order to turn our robot, we take this steering parameter, and with a slider where we can turn to the left or turn to the right. The further we turn or move on the slider, the larger the number, the tighter the turn will be. So if we just kind of like turn a little, it'll make more like a wide circle. And if we move it all the way around to 100, it'll make a very tight turn. Now the arrow here indicates that the robot will turn to the right. Whether that is actually going to happen or not depends on how you connected the motors to your EV3 brick. Here, the program assumes that motor B, or the motor connected to port B, is on the left side of the robot, and the motor connected to port C is on the right side of the robot if we look at the robot in the go straight forward direction. So if your motors are connected that way, then it will actually turn right. However, if on the left side you have the motor connected to port C and on the right side to port B, your robot will turn in the opposite direction. So by just kind of like swapping the connection wires, you can make the robot turn in a different direction. It is a good idea, however, to connect your motors to the brain in such a way that if the program suggests with the arrow that the robot will turn right, then it actually in reality will do that when the program is executed. So how far will our robot turn with that one rotation at power level 50? That is something that for now you can only test. It depends on a whole bunch of different specifications of your robot. For example, how big are your wheels? How far are your wheels apart? So you really just need to test the program at this point, and then if your robot turns too much, you can either reduce the number of rotations here, or you can make it a wider turn, or you can adjust both of these parameters. We can also use the move tank block to create a turn. In this case, we would do it by changing the power levels of the motors. For example, if I make this 50 and negative 50, then now the motor connected to port B, or the left motor, hopefully, will turn backwards, and the right motor connected to port C will turn forward, and the robot will make a turn. So with the left motor turning backwards and the right motor turning forward, the robot actually will make a turn to the left. You can also say, let me just not move my motor B, it'll stand still, and have motor C go forward, and it will still do a left turn. So, and then again, depending on how far you want to turn, you need to test your program, and then you can adjust the number of rotations. A third way to create a turn, is by just using one motor, as I've shown you before. So here we've set this motor to power level 0, so it won't move. That's the motor B. So we can as well just take here the large motor block. Let's make this a little bigger. Okay, now by default, this is now set to port D. If we want to turn left again, we just want to move the right motor. So we can just operate motor C, and, well, there's nothing being said about what motor B does at the moment, but that means motor B will stand still. So the only thing we now have to do is to save our project. And now you have all the information you need to make your robot go forward, reverse, and to turn.